part of all dictionaries. Look up using the key W, which is the, and if I don't get it, give me back 0. And so I'm going to say print word, comma, old, comma, old count. And now what I can say, whatever the old count is, it's either the value that was in there or 0. And now I can say new count equals old count and now let's see, new count, and I can say dictionary sub word is equal to new count. So instead I'm going to get rid of this if then else then. This is basically saying look up the old count that we have. If you don't find one, use a 0. We'll print that out. And then I'm going to say afterwards I'll print the new count. Now, and so we'll print the old count. Here are some of these blanks. Print the old count. And you can see the old count with the, because the doesn't exist, was 0. The new one's 1. Clown's old is 0. New is 1. Clown's old, ran, old, 0. But now we get to the, its old count was 1, and now its new count is 2. Okay? So by using this get and saying if we don't find it, we'll assume the count is 0. That makes a lot of sense, right? You know, if not there, the count is 0. If the key is not there, the count is 0. Okay? So that's what this line does. If get the value from under the key associated with the key, or give me 0 back. And then I can take that old number and just add 1 to it and then stick it back in. Now this is ultimately not how we tend to do it. Okay? We tend to blend this all into one big long statement. di sub w equals this part plus 1. Okay, so that says get the old value from this key or 0 and then add 1 to it, because that really combines all of these lines into a single line. Okay, so I'm going to delete them now. And now we've combined this all into one, what effectively is an idiom. Retrieve, create, update, counter, all in one line. I'll still print out, in this case I'll just say di sub w, and then we'll see the counter. Okay, and so now I'll run this. We have a new, but now we see it the second time it's 2, and so we see car the first time, we see that the second time, we see car, the third time, we see car the second time, and away we go. Okay, and so that's pretty straightforward, and so it really kind of, a typo there, so let's just get rid of that and run it with the clown stuff, and we get the right data there. And let's run it with intro.txt. And there we go. Okay? And so it's tearing out a bunch of words and giving us a dictionary. So that was a lot of work to get to this line 16 that has the dictionary in it. Now we want to find the most common word. And so we're going to loop through this dictionary, and part of it is like, once we printed this dictionary out and we verified that it's right, don't worry too much about the code up here, right? Matter of fact, I can take out some of these print statements, and we can kind of trust all this. And so now we're going to work on this. Okay, now we want to find the most common word. Now this is like a maximum loop. So if you recall, we have a whole set of key value pairs. Communicate goes to 2, is to 2. Skills is 3. So we have these key value pairs, and we're going to loop through and look for the maximum. Now, in a dictionary, we can loop through the key value pairs with the following syntax. For, I would call these variables k and v for key and value, but in the dictionary's name dot items. And items is a method inside of all dictionaries that says give me the key value pairs, and we need 2 iteration variables. So this is like an assignment statement for k and v. K and v take on the successive values for the key and the value. Okay? So if I just now print k comma v, and I'll take this print statement out and then run the code on, oops, what I forgot to, oh, I fell back into my Python 2 days. Need parentheses for my print. So there's clown, and it just prints it out. And it's kind of the same thing, except it's pretty, where we're putting each one on a line. Okay, so the v is the value. So we're looking for the largest value. Oops. So the thing is, we know that the values are always numbers that are greater than 1. So I'm gonna do kind of a quickie maximum loop. Largest equals -1. Now in previous times we've seen that this is a bad assumption, but because we know these are counters that are always positive, it turns out this is not a bad idea. And so I can say if the value is greater than the largest we've seen so far, largest equals the value. Okay, and when that loop is all done, we can print the largest. Okay, and so this is just a max loop, and we're using this value. That's the number. The value is the second thing. Oops. Can't type Python. Oh, it's a typo. Yeah, I'm not using value, I'm using v. So largest equals v. Let's try it again. Okay, so we're all done with 7. So these were the things that we were looking for, and it was looking for the maximum, and it just dutifully found 7 was the largest. But we also want to know what the word is. And so what we can say here is we can say the word is none, meaning it's just like we don't know what the word is. And then whenever we catch this new largest number, we say the word equals W. So I like to think of this as capture, remember the word that was largest. Right? That's what I'm doing. Remember. Right? That's tough. R-E-M-E-M-B-E-R. There we go. So we're gonna this trick here is not only knowing what the largest number was, but the word that was associated with the largest number. So now I can print out at the end the word and the largest, and that's the count. Okay, and so now we know that. Oops, did we make a mistake here? Okay, that does not look good because it says car and 7. If V is greater than the largest, oh, it's not W. I used a really bad variable. See, that's the whole value there. There we go. It's K, which is the key. Key. was going to say, that was quite the bug. See what happened there? I had this as W, and it just happened to be, it was the last word on the